Here's the next question, number 48. A 3-phase 50 Hz salient pole synchronous motor has a per phase reactance XD of 0.8 pu and a per phase quadrature axis reactance XQ of 0.6 pu. Resistance of the machine is negligible. It is drawing full load current of 0.8 power factor leading when the terminal voltage is 1 pu per phase induced voltage in pu is dash. Per phase induced voltage is what we have to find. So we have been given frequency 50 Hz, salient pole synchronous motor, XD is 0.8 pu, XQ is 0.6 pu, power factor cos phi is given to us as 0.8 leading, and the terminal voltage Vt is 1 pu. So this is all that we have. Now when the question says salient pole synchronous motor, there are a couple of other terms that you have to remember and note. The angles psi, phi is what we already have. Let me note that down as well. Phi and delta. These three angles are quite important. While psi is the angle between induced voltage and armature current. Induced voltage is what we need to find. Okay, let's call that E. Armature current is IA. Now phi is what we have. That's usually referred to as the power factor. Now the phi is the angle between terminal voltage and armature current. Vt and Ia, while delta is the angle between terminal voltage Vt and the induced voltage E. In order to find the per phase induced voltage, we are going to come across all of these three types of angles. Now this will really help. Okay. Also, now since the question says that the resistance of the machine is negligible, we can ignore the armature resistance. Okay, so this is all that we have for now. Let's let me just get another sheet of paper. Okay. Before we go into that, now cos phi is equal to 0.8 leading, so that would give us what the angle of phi is. Let me write it here. So we have cos phi is equal to 0.8, which means that phi is equal to cos inverse of 0.8, and that comes around to 36.86 degrees. Now the next step is to find out what psi is, and to do that we can use the standard formula of tan psi. Tan psi is equal to V sin phi plus IAXQ divided by V cos phi. Okay, so you should know that V is the terminal voltage given to us, Vt, and Ia is also 1 pu, though it has not been mentioned that Ia is 1 pu. We take it as 1 per unit because the question mentions that it is drawing a full load current. So in considering the full load current, we always take a whole number of 1. So the armature current is 1 pu and the terminal voltage is 1 pu as well. So if we substitute all of these values into this, we will be able to find out what psi is. Vt is 1, sine of angle 36.86 plus Ia is 1, xq is 0.6. That's the quadrature reactance given to us. 1 times 0.8. So tan psi is 1.2 divided by 0.8, which gives us psi would be tan inverse of 12 by 0.8. Oh, that's 1.2 by 0.8. 56.3 degrees is what psi is. Now for leading power factor, the question mentions that it is power factor 0.8 leading. So for leading power factor, the relationship between all the three angles is psi is equal to phi plus delta. Now we know the values of psi and phi, we can easily find what delta is. So delta would be equal to psi minus phi. That would be 56.3 degrees minus 36.86. So that gives us a delta of 19.7 degrees. 19.7 degrees. So now that we have delta value, we can find out what the induced voltage is. The induced voltage equation, E is equal to Vt cos delta plus IdXd. Okay, so here we have one more unknown value, term, Id. Now we don't know what Id is. So Id can be written in terms of Ia, that is the armature current into sine of psi, sine of the angle between the induced voltage and the armature current. So Id, once you solve, that's 1 into sine of 56.3, it gives us 0.831. So substituting Id value, Xd value, Vt value and cos of delta 19.7, we will be able to find out what the value of E is. So I'll just flip this sheet over so that I can write down that portion as well for you. So we have E is equal to Vt cos delta plus Id Xd. Vt is 1, cos of 19.7 plus Id is 0.831, Xd is 0.8. Solving, we will obtain a value of 1.606 volts. So this is the value of the induced voltage. So I'll write that down here, 1.606 per unit. I hope this has helped.